Hi, this is Mary Beth Hendrick. I'm here with my in-depth analysis of an NSF video. The video that I chose was Learning Labs, Math and Science Support for K-2 Teachers. This is a proposed learning lab for teachers. It is still under development and they are still piloting it. And the goal of this is to find a way that teachers, that they can show exemplary STEM practices and online teacher collaboration with the hopes to enhance K-2 math and science instruction. John Ward is the overseer or creator of this. He was very responsive in the public discussions that you saw at the bottom of the NSF video. Unfortunately, that is closed now. I did try to find him, but there are many people named John Ward who are working in science and education fields, and I had a hard time tracking this John Ward down. So like I said, the public discussion is now closed. It evidently closes after a certain amount of time. But in his responses to people that did get in the public discussion, he provided a link. And that link took you to the teaching channel, where there are 13 videos associated with this program that would be used as part of the teacher training for this program. The videos are all 4 to 10 minutes in length, and I found the videos to be really wonderful to watch for ideas and guidance. Here's some features. There's the videos, but once you click on a certain video, there's a lot of extra things besides watching the video. For instance, you have a lesson objective, what the teachers were trying to do, the length of the video, which is 5 minutes, and it gives you questions to reflect on and think about while you watch the video. It also has teacher responses from teachers that have watched the video and what they felt was helpful about that video. There were support materials available, and I went to sign up, a little worried that that might be something that costs you money, but it does not. I was able to sign up for free. And once I signed up for support materials, here's some things I found. Here is a lesson in part and whole relationships in math. There were cards, you can't really see them very well here. There were cards you could print out, and then an example of how you would use them in the classroom. There was also some whole lesson plans included with some of the videos. And the videos each provided a little button you could click on for the standards. You click on those standards and it's going to show you the age and how it relates to the Common Core standards for that grade level. Okay, so let's take a look at how these learning labs have reflected the STEM attributes that we've been working on in Model 1 and Model 2. So here, Module 1, we were talking about developing and using models. And these are kids in a kindergarten class, and they had been shown many examples of how the teacher used models to show their thinking and their learning. And this is a final model from a kindergarten class answering the questions, where does a puddle come from and where does the puddle go? The students have been working on this question for a long time using lots of different resources, and this was kind of the final one that they chose. So there are kindergartners already at age 5 or 6 using models to represent their thinking. Also in Module 1, we talked about engaging in argument from evidence. And this was which of these, they were noticing the similarities and differences between those and which ones go together. So now the student up here was pointing to these two, saying these two go together. But she had to explain and defend herself. Why do they go together? So she could visually see that there were some things alike about them, but struggled a little bit to explain it, which was something they were working on. Another child came up and said these three went together because they were the ones that had curved lines and not all straight lines. So I like that none of the answers were correct or wrong. It was more, the focus was on the children being able to explain their thinking and creating their argument from evidence. Module 2, some things I found that would match with Module 2 is learner engages in scientific-oriented questions. So in this video, the teacher had looked at a model of the inside of a leaf, and then she was handing out the leaves, and they were talking about the inside of the leaves and their function. And so I like that each child had a leaf to hold on to, and they were looking at the veins and talking about them. The other thing I also liked about this is this teacher took one page from a scientific text, and she really focused on the information in that one page. Now, I often read a whole scientific text and then go back and focus on one page, but it was really neat the way using just that one page, they really, really worked on their focus. Let's see. And this one was a math task, 3-addition modeling. And here the learner was communicating and justifying their explanations. She had done, they call it 3-act math. First, they watch a video or engage in talking about a picture, about what they notice about that picture, what question looking at that picture or video generates. And second, the teacher picks one question to be answered, and the class identifies what information they will need to answer that question. And then the third one, the children go off and work on answering that question and showing their thinking and justifying how they solved that equation or that math problem and why it was correct. What I liked about this is over here, these notes I'm showing to you, they're my notes. As I was watching the video, there were parts of it and a system to it that I wanted to remember. So there is a place over here that you can click on Add Notes, write down your notes, and it saves them for you. So if I'm using this video in a future in-service presentation or to share with my colleagues, I have my notes right there that I can share. Love that. And here's the child showing how he figured out how many candles on a birthday cake. There were 9 blue and 6 yellows. He made some cube trains, one of 9 and one of 6, counted them all, and showed his response. The great thing was not everyone was using cubes. Some kids were using their fingers and quickly realized they'd need not only their fingers, but fingers of a friend's. And other kids were using other ways, tally marks and such things, to solve this problem. So I liked the open-endedness, that as long as they could communicate and justify their explanation, they could use any materials they wanted. Why I chose this video collection? Well, I'm a kindergarten teacher, so I chose it because it was relevant. Sometimes when you look at STEM videos, there's a lot of focus on high school. And so I really appreciated that this one was geared for kindergarten and first grade. I like the use of videos because for me, those teachers are good models for me to engage in good STEM practices. I like that there were ideas on how to approach scientific questions, and I really like that focus on one page in a book, whereas a whole book can contain so much information that getting a question out of it would be overwhelming to the best of us. I also like that there were great ideas on how students develop their thinking and their ability to defend it. In some of the videos, when they were showing a great example of a student defending their thinking, they did remind us that when they first started engaging in this kind of discourse, it did not look like it did in the video. It started out much more basic. So I appreciated that as a teacher, that that's something to keep in mind, that justification and communication is something that grows, and you need to start slow with the kids. So thank you so much. I hope you guys also found as many great videos to watch, and we'll see you again in Module 4.